On some rational functions, a situation like this could occur. True enough, all right, so x here cannot equal 5. Denominator equals 0. However, a little something different is happening here. Because previously, on our rational function, we would have said, well, that's denominator equals 0. That's going to be the vertical asymptote. Here's why that's not the case. Look at the top here. The top factors as 2 times x minus 5. And the bottom has that x minus 5 there. Do you notice something about that? They have a common factor, yeah. And so this is why there's not a vertical asymptote at x equals 5 in this case. Because, technically speaking, the x minus 5s cancel out, which sort of gets rid of your vertical asymptote, okay? And so that's because there is an x minus 5 factor on top. On the previous ones, we didn't look at the factors on the top, but none of them had a common factor top and bottom. And so if you have a common factor top and bottom, you don't get a vertical asymptote at 5, or wherever the denominator makes 0. Now, what happens here, if I just start doing values, and wherever we want to, but let's just say we look at the values off of this. So x equals, let's just do 1 and 2, 3. So if x is 1, we've got 2 minus 10 over 2 minus 5. 2 minus 10 over 1 minus 1. Which is negative 8 over negative 4, which is 2. This one gives me, x is 2, gives me 4 minus 10 over 4 minus 5. So that's negative, whoops, 2 minus 5. Keep wanting to do 2 on the bottom, but it's 4 over 10 over 2 minus 5 because it's just x on the bottom. So it's negative 6 over negative 3, 5 and 2. And then at x equals 3, we have 6 minus 10 over 3 minus 5, right? We got negative 4 over negative 2. You see something?
It's a straight line.
It's a straight line, it's 2, okay? And do you notice something else? If I cancel those out, what do we got? 2. All right, I got 2. All right, so here's the thing. Yeah, this graph is the graph of that, with one little exception. The original function was this, right? Which simplifies down to be 2. However, on the original function, isn't that still the case? X can't be 5? So we've got to do something a little different at 5. So here's what happens. If I graph these points, yeah, it's just a horizontal line at 2. All the y values are 2. Until I get to 5. At 5, though, it's undefined. So there's a break in the graph at 5. And then it picks up. So here's what happens. There's a hole at 2. I mean, a hole at 5. So this graph doesn't have a vertical asymptote at 5. It has a hole at 5. And why was that? It was because of that common factor that I canceled out. The denominator can't be 5. But the top also has x minus 5, so yeah, so you get a hole in the graph. When you have this common factor, what that leaves is a hole in the graph, okay? When you have a common factor like that, it gives you a hole in the graph, okay? So I got one more here lined up. All right, so take a look at this one. All right, so f of x equals x squared minus 4 over x plus 2. Well, this one also has a common factor, doesn't it? Because at the top, I've got x minus 2 times x plus 2 would be the factors. So the x plus 2 do cancel. It just leaves me x minus 2, but what does this leave me? That's a whole at where? Negative 2, right? Where it makes, what makes this 0? So it'll be at negative 2. All right? But now look at what I've got left is f of x equals x minus 2. What kind of graph is that? That's just a line, isn't it? A y equals mx plus b line. Except what? It's got a hole in it. So if I graph y equals x minus 2, that's basically what I'm graphing here. M is 1, b is negative 2, so that's y-intercept's negative 2. M is the slope, so rise 1, run 1. Rise 1, run 1. And so it gives me this line, except at negative 2, it's got a hole. So when I get to negative 2, I put a hole in it. And the rest of it follows suit. So it's a little interesting little tidbit there. You get holes in these functions this way. If you've got a common factor, there's a hole in it. That's what happens.